want to know what happens when an LED scene light overheats? We took these two fixtures that have the same circuit board on them and machined the back off of this one so that we can show you the effect of temperature on an LED scene light. As these things get hot, you'll see light output drops, and sometimes by as much as 40 or 50%. So here's the setup. Right here, these light sensors measure how much light's hitting him in the face. As you follow it over, we've got two fixtures side by side. This fixture operates normally, it's got a regular heatsink on it, and this one does not. So we're gonna turn them both on one at a time and measure how hot the fixtures get and correlate that against how much light's hitting our firefighter in the face. So when we do these two tests, what you'll look at here on the bottom, this is the test showing the fixture with a heatsink. And so as the circuit temperature increases, we know based on the LED chip manufacturer's rating system that it should not exceed 85 degrees Celsius at the junction. So we're able to dissipate as much heat as that circuit board is generating into the atmosphere passively without having to do any kind of computer control circuitry to reduce the heat, because that housing is big enough. So as you see this reduction, we only lose about 8% of the light output, and that's just natural going from air temperature to operating temperature. So as we change and look at the fixture that we machined, what you'll see is a significant difference, where we're increasing in temperature down here. Once we hit that set point based on this tech sheet, the drivers on board are smart enough to know, okay, this thing's getting too hot and I've got to make an adjustment. So right here at about the 20-minute mark, it starts backing off the amount of forward current that it's giving the LEDs and more or less dimming the circuit to keep it from overheating. Because there's no heatsink, it can't passively get rid of that heat. So it's got to actively turn that computer circuit on and start backing off the drive current. So what that results in is a light output degradation that starts off fairly natural and then quickly turns south until you reduce about 40% of your light output over the life of that incident. This incident was 1 hour. So when it comes to an LED fixture, when you're out trying to spec apart or you're looking for what sets different manufacturers apart, it's important to understand the temperature of the circuit and how the fixture is going to perform over the life of an incident. So say it's an hour, say it's 3 hours, you want to know what happens when that fixture gets hot and how much aluminum there is in the heatsink to dissipate the heat generated by the LEDs so that the active drivers don't have to kick on. Something that's important to understand is that the LED chip manufacturers themselves produce these sheets that allow for the LED device manufacturers, like the light manufacturers, to look at the parameters of the chip and make determinations based on how hot the circuit should get and how much power the circuit should consume, as well as how much light it should produce. But it gives you all of the data beforehand so that when you're designing the LED fixture, you can do some things with the driver circuit, which is kind of like a mini computer that controls how hard to push the LEDs to keep it within the parameters set by the LED chip manufacturer. Thanks so much for watching. If you have questions about how thermal degradation affects scene lighting on your fire trucks, feel free to reach out to the HiViz team. We're available online at HiVizLEDs.com or check out our Facebook page, facebook.com/scene lighting. Have a great day.